plans are, today we're going to do Euler, tomorrow we're going to do differential equations, Friday we're going to do the exponential differential equations, which is probably what you're going to see on the exam. So those are the most important ones. Then on Monday we're going to do the logistic curve. Put your phone away, please. No, you don't. Later. Okay, so that's what we're going to do on Monday. Then Tuesday I will not see you. Wednesday, I will see you. Wednesday is going to be a work day. Wednesday night is the beginning of our review sessions. Okay? Wednesday night and Thursday night. You don't have to. Yes. So if you know HL people who are going to take the BC exam, I highly recommend they come to the study sessions. And I bring my doggies. These little guys are going to come with me, Mickey and Minnie. No, a week from tomorrow. Today, I mean. Today's Wednesday. Next Wednesday, Thursday. No, it isn't. Guess when the exam is? 4 weeks.
Oh, isn't it like 2 weeks to review and then a week off of like just like our own day? We don't do
You should.
We don't do review sessions all the way until.
Yes, we do. Pardon? 6 until 9. You don't have to come for the whole time. You just come when you can. No, we'll do the BC ones. Now, what I'm going to do next week on Wednesday, hopefully I will do a little bit. Wednesday, I'll review this chapter. So I will review differential equations just to make sure you have that, because I firmly believe that will be on the exam as a free response question. It has been for several years. And what's BC topics here would be the logistic equation, which we talked about. I haven't formally done it yet. That's Monday. And then Euler's method of solving differential equations. So we'll focus on this chapter on Wednesday night, maybe Thursday night if necessary. Otherwise, I may go back and I'll have to see. I'll see what I did last year. I may go back and get the polars done. But the polars are going to be big for you. So this is 2 weeks out of the 4 weeks we have left before the exam, where class time is not going to be used for reviewing. We're doing material. Okay? So that only leaves us 2 weeks of review. Which is not a lot of time. So you need to be reviewing on your own already. But if you focus on the differential equations, that will get that out of the way. Okay? Now, what we did in Chapter 7, Alex and John, was in the first section, we talked about qualitative characteristics. So what that tells us, this is like a mini unit on differential equations that you're going to take in college. This is kind of an overview. Okay, Zach? They're qualitative characteristics. You are given the slope, not the function, and you can then have an idea what the function is going to look like. If the slope is positive, you know the function is going to be increasing. If the slope's negative, the function's decreasing. So that's what you mean by qualitative. Quantitative is when you actually solve the differential equation for an algebraic solution, provided that one exists. No guarantees. Most they don't exist. Okay, so that was section 1. We just talked about that. We talked about exponential growth and the logistic curve. Then in section 2, and this should say 7.2 actually, because it was 7.3 in the old book, but 7.2, we did slope fields. We looked at differential equations, and we looked at a slope field as a way to see what the solutions for the function might look like. It's just a picture. I don't know what the function is. I haven't solved it. I'm just looking at what the pictures are. This is another way to do that, okay, the Euler's method. It's very similar to slope fields, except you're actually going to do calculations, and you're going to plot some points on, not on the curve, but close to the curve. So the first thing here is to write the equation of a tangent line. And if we can't do that, we're in trouble in everything in the exam. You have to be able to write the equation of a line. So it's y minus y1 equals m x minus x1. You got to be 100% on that. We've been doing it for a long time, and that is not calculus. So when they asked me for the equation of a tangent line, I write down the equation of a line, and then I look at it and say, well, I need to know the y value, I need to know the x value, and I need to know the slope. So here is my ordered pair. I want to write the equation of the tangent line at x0, y0. It's going to be my beginning point is what it is. So it's going to be y minus y0. How do you find the slope? It's the what? Alex, this is new material. It's the derivative. So now we can have our derivatives could be have x's and y's in it. So you might see a little multivariable calculus. It's going to be f prime of x and y, but we're going to find the derivative at that point, x0, y0. And then it's x minus x0. Solving for y, we all know how to do this. Y is equal to the initial y value plus the derivative at that point times x minus x0. And I would hope you recognize that's a Taylor polynomial. It's the first order one. This is f of a. This is f prime of a. And then this is x minus a. That's the linear approximation is the first order one. Okay, Nick? What would the next term be? Plus, you remember the next one? Second derivative divided by 2x minus a squared. You need to make that connection that when you write the equation of a tangent line, you are actually doing the first order Taylor polynomial. Because they're probably going to mix this up, and actually they did in 2012. Okay, so the formula is this. I'm going to do one little change. It's y is equal to wherever you start, y0. So if I wanted to find another y value, the next one, I'm going to follow along the tangent line. So here's x0. I'm going to start here, and I'm going to find another point. It's not going to be on the curve. It's going to be on the tangent line. There it is. Call that x1. Okay? I could find the y coordinate on the tangent line. It's not the same as the real one, but it's not bad. If you keep this distance small, this distance here is going to be called h. That's the step size. So it's going to be y0 plus the derivative at that point. And then this is the step size. We'll call that h. That's the formula. I don't memorize the formula. I write the equation of the tangent line and figure it out every time because it's just easier. And that gives me the next coordinate. So then, now I have this coordinate. I've got x1, y1. I forgot the ones though. And I'm going to start at this y coordinate, and I'm going to find my slope at this point, and I'm going to probably go off like, oh, I should probably change color. Maybe the slope here is steeper, isn't it? So it's going to probably be steeper. And I'm going to find this point on this line. And then I'm going to do another one, maybe, depending on how many times I have to do this. And I find this slope and do that one. And you got a pretty good approximation to the curve. It's not exact. It's an approximation. I use this when I can't solve algebraically. So the algebra, that's tomorrow. How do you solve differential equation? So all we're doing is finding points on these little lines and plotting them, which is probably how your calculator works. Calculator does not know what e to the x is, but it does the tangent lines. Okay, so do you remember that from yesterday? Forgot to bring my calculator up, I think. Remember we did that slope field yesterday? Yes? Yeah, I didn't bring my calculator. Let me bring my calculator up. I'll get that picture.
Why did you have to multiply?
Because we're not adding it, we're multiplying it. If I can get that to go away. It is, but we call it h. Same thing. There's our slope field from yesterday. So you're right, it's x minus x0, but that's what they call the step size. They're going to give you the step size. They're going to say, do a step size of 0.5. So every 0.5 along the x-axis, we are going to calculate a y-coordinate, and then we can graph it. And I want the slope field there because it's going to help us see what we're going to do. So let's first, before I do this, as I meant to do this, I'm going to give you problem 20, and I made copies for you. This is problem 20 out of the book. And the solution is not online, so we might as well do it. There's 4 questions for homework. This is one of them. So let's visualize what's happening. I've got a slope field here. Let's call it a direction field, same thing. Might have an extra one there, I'm not sure. It just takes getting used to because it's new. But I'm really just using lines to find another point that's pretty close to the actual function value. And we will do problem 19, which is in the homework, together, and we'll actually compare it with the real value. Because that one we can solve. The one x plus y, I don't think we can solve. I don't even know what this one is. So first we're going to do, we'll just use the slope field. Everybody get a little handout? Did I miss anybody? Okay, read the directions. Okay, there it is. Okay, guys? Just so you see what we're doing. This was a new approach this year. Now, you're supposed to have a ruler. And it says, well, first off, let's just do the slope field. We're going to start at the origin. So this points me this way. I follow the little arrows as best I can. Looks like it's pointing me somewhere like that. Origin, because it said to start at the origin. There. Happy? Close enough. Okay. Now we're going to do a direction field. We're going to draw with a ruler, well, except I'm not going to use a ruler. Actually, maybe I will. I can cheat. No, if you look at the slope over here isn't as steep as some of the ones over there. So this one's the slope of 1. That looks like a slope of a half. So we're going to do a step size of 1. So we're going to stop at 1. We're just going to take this. I'm going to follow that direction. It's okay. There. And then I'm going to see how this one's not as steep. So now I'm going to follow that one. It's a straight line because my step size is 1. Yeah, that's what's asking you to do. So I'm going to just change the color so we aren't. It's okay. You're going to put them on 1. I'm doing it because I got more than 1. I suppose I could have given you 2, but I didn't think about it. Okay, there it is. Now, there's the actual graph. It's not too bad. But what do you think happens if my step size is smaller? It's more accurate. Okay, so I'm going to go in, and I am going to start here, and I'm going to stop at 0.5. It's going to be exactly the same until I get here. Then it may change a little bit. Looks like it's not quite as steep. So I get to 1. And then it looks like it's pretty much like this. And it looks like it doesn't change much there either. It looks a little more accurate. Smaller your step size. You can have segments still, but if you get your segments really tiny, it's going to look like a curve. Right? That's all you had to do on number 20. I figured you guys wouldn't do it, so I figured I better do it with you. Because that's what you're doing. You are going to calculate this ordered pair right there, and this ordered pair right here, this ordered pair right there, this one, and that one. You're just going to do it with numerical calculations, and then you could graph those points, connect the dots. So this is just doing the visual piece. Okay, so let's do this problem, and then we're going to do another one. We'll do the one out of the homework, sorry. What happened? Oh, it's going to be difficult, isn't it? That might work. Ha! You just got to trick it. Okay. Let's look at this. Let's look at the slope field first to see what this should look like. And it says I'm going to start at 0, 1. So 0, 1, I think is about here on my slope field. I'm not exactly sure. If you have Euler 2, you should be able to graph the particular solution on your graphing calculator. I'm pretty sure that's the one. I don't have it. It's a program. It's called Euler 2. First you do this. I don't even know if you have to do the slope field first. And this points me up this way, and this is pointing me up steeper and steeper. So it looks kind of like that. What if we had started down here? It wouldn't look like that at all, would it? It would be looking like this. Okay? Depends on where you started, so what it's going to look like. But the red one is what I'm trying to get. So, and by the way, sometimes they go backwards. Yeah, like this is going to find, we want to find a step size of 0.5, so we're going to stop when we get to 2. Well, they'll tell you. Well, we're going to stop when we get to 2. But they could have started at wherever the point is, at 2, and gone back. Or they could say the step size negative 0.5. So you could be looking at that. Okay, Eric, so what's my starting point? Where am I starting? It says so right there. 0, 1. You know what I'm going to also do? Before I do this, I'm going to take a picture of this. No, I'm not. Okay. We haven't done anything. It tells me. Why is it doing that? Read the directions. Yes, it does. Oh, it doesn't on yours? Well, it does on mine.
So really, you asked me a tough question about it.
Okay. Get rid of that for now. It's not going to help, actually. Okay. It says going through 0, 1 with a step size of 0.5. I might have missed that, but we're going to do that. We're going to start right here. 0, 1. And the slope is x plus y. So it's 1. So then you take the y value where you were, which is at 1, and you add in the slope times the step size, which is 0.5. So I'm going to end up with what? 1.5. Now, on the exam, we had a big discussion as readers. They really thought it wasn't a good idea to have the table. I personally think it's a great idea. It's way easier for me to read. Okay? No, they won't give you the table, but you can do it. This is the y value. This is f of a. This is f prime of a. And this is x minus a. It's the equation of a line. That's the new y value. So this is going to be my new y value. What's my new x value? The step size is 0.5. 0.5. What will my next x coordinate be? 1. Okay, I need to find out what the y value is. I guess we'll stop there just at 1. That's how many, these are called iterations, and this is how many times you're doing it, so it's just a counter. Well, that's why we're going to do this a couple times, and we'll do the homework problem. Iteration, where you repeat the same process. Okay, what's the slope here? It's x plus y, right? What's that slope then? 2. So it's the previous y value, which is 1.5, because that's where you left off. And then you're going to have a slope of 2. And the step size is 0.5. So what's that going to give you? What's 2 times 0.5?
I'm gonna go with 2.5.
It's, what is it going to be? 2.5. Good. That's just what they call it. The line. That's the line. Okay, you guys, I can't hear. Why do I have to do what? This? I'm trying to find the next y coordinate on the line. That's how you find it. Okay. I think I made a mistake in my other class, but that's okay. Okay, what is the slope? 3.5. So it's 1.5. Oh, sorry. It's 2.5 plus the slope 3.5 times 0.5. Because that's what we found here. You are, let me redraw this. You are starting at 0, 1, and you are going to do a step size of 0.5, and it's going to be up to 2.5, so it's here. So you're drawing this one. That's where you start. That's at 0.5, 2.5. Then you will start there. Calculate the slope of the curve at that point, at this point, and you're going to find another point up here, which looks pretty good, actually. Okay, so let's do that calculation. Oh, did anybody do it? 4.25? Do you guys agree?
Yes, I'm always.
Okay. Does that kind of look like my curve here? Yeah, it does. So now let's do the same thing again. That is giving us a picture of the solution curve going through that particular point. Notice that if I start with a different point, I might get that solution curve. So it'll be different. If you started here at 0, -1, you're going to find values that go down there. We're just trying to look at the picture. First section, we looked at what does the derivative tell you? It tells you if the function is increasing, decreasing. Second section was looking at slope fields and using a slope field to try to graph our functions, and we could find particular solutions. Could be population. And then this is just another way to handle a differential equation. Like when you solve systems of equations. You remember what a system of equations is? Hey guys, do you remember what a system of equations? Two equations with two unknowns. So if you talk about linear systems, lines will intersect or be parallel or be the same line. And you had many ways of doing that. You could graph them and find where they intersect. You could use substitution to find where they intersect, or you could use elimination method. Variety of ways to do this. These are two ways to look at differential equations, especially if I don't know how to solve the differential equation. I can get an idea what the function looks like. So if I made my step size smaller, do you think it's going to be better? Yeah. So let's try that. This was dy dx is equal to x plus y. Okay, we started at 0, 1. What's the slope? 1. So it's the y value plus the slope, and the step size now is not 0.5, but it's 0.1. Now I don't memorize this equation. It's the equation of the tangent line. That's all it is. So what's this going to give us? 1.1. What's my next x value? Not 0.5, 0.1. You're saying you're going to plot x values every 1/10. Then what's the y value? 1.1. What's the slope then, Marshall?
Slope is 1.1.
No, 1.2. So you're going to start here at 1.1 plus the slope, which is 1.2, times the step size of 0.1. So it's 1. Now, by the way, if that's as far as you needed to go, you could leave it like that. Do not simplify, but we're going to. Plus, that's 0.12, so it's 1.22. And where are we on the x's? 0.2. If they told you only to do 2 iterations, you stop there. Even though the chart's empty, that's okay. Don't go further than what they ask you to do. You can think that you're making an impression, but you're not. You're going to get points taken off.
So when you're determining your X, you're going up by the step size.
That's right. The X is determined by the step size. Okay, so let's look at number 19. Oh, should we graph it? I mean, we could graph it. You're starting at 0, 1. You're going to go 1/10 over, and you're going to get to 1.1. You see, it's not going to change much. There's the first one. And then you do one more, you're going to be up to 1.22. Because remember, your step sizes are really little. Now, I'm going to go back here and copy that little chart maybe. It's not great. We're going to do number 19. So I'm going to need my book. And let's see if I can make that a little smaller besides. Okay. Now, they tell you that they want you to find y of 0.4. It's really f of 0.4. That's what they're asking for. An approximation. Okay, you guys? And now I need my books. I haven't memorized it. But you know what? We're going to know this one. We can solve, we're not going to solve it. We're just going to do this by inspection. Okay, so this is 1 out of the 4 problems. Eric, put your phone away, please. Do the homework. You guys, after the exam, I don't care if you play games. But right now, we need to be focused on this. We have 4 weeks. That's all. No, we have to do something.
No.
That's directed at us by the school board. Okay, so it's not a choice. No. Unless you want one. Well, that's a way to change your grade. No, you have to be here. Remember, this is all new material. Okay, there's my differential equation. Y prime equals y. I don't like the way that looks. It's dy dx equals y. And we know what that answer is. We know what that function is. What is that function? No. The derivative of what function gives you the same function back in e to the x, like a phoenix rising out of the ashes. Yes, we did. Okay. I want to find y of 0.4. So we're starting at 0, 1. And what's my slope there? It's equal to the y coordinate, which is what? 1. But there's something interesting. Okay, Alex, you guys, this is your homework. You should be doing it. I could collect it before you leave today. Yes. So this is 1, because this is all new material. And when you walk into the exam and you see this on your free response question, you don't have time to be figuring it out. You need to be doing it now. So this is going to be my previous y value, which was 1, plus the slope. And what's the step size for part 1? It's 0.4. So it's 1.4. So this is at 0.4, and this is 1.4. Am I done?
So when it gives you an H,
That's your step size. It's just the equation of a line. Remember, it's y minus y1 equals mx minus x1. So solving for y is equal to the y value. That's that. Plus the slope, which is dy dx. And we called that the step size. It's the same thing. Okay, remember, that's how I teach. That's how I do things. I haven't memorized it. I will admit that this was one of the lessons I looked over before I came in. They're not going to give you the table. You'll have to create it yourself. Okay. No problem. Right? Let's do the next one. Now, you got to think for a second. Okay, where are we starting? This is actually, this got an interesting result, which I'm not exactly sure why it is what it is, but you'll maybe recognize it. So dy dx is 1, and we're starting at 1 plus 1, and what's the step size now? 0.2. So this is 1.2. Where's my x value? 0.2, 1.2. Am I done? No, you got to get up to 0.4, because that's what it asked for. So what's the slope here, Eric? There? Ori? It's 1.2. And so you're going to start with 1.2 plus 1.2 times 0.2. Pardon? dy dx is equal to y, remember? Did I do that right? So 1.2 plus 0.2 times 1.2 is what? 0.24, right? Oh, I just noticed something else. What's 12 squared? Or 1.2 squared? 1.44. Okay, we got to do this again, don't we? Andrew. Because it's the y coordinate. Remember, dy dx is equal to y. Guys, I can't hear. What? This is a different function. Just worked out. Wait till you see what happens with 0.1. Okay, so this is going to be now what? Step size of 0.2 is what? Eric, I don't care if you don't pay attention, but you need to be quiet. So this is what? 0.4. Then the y value was 1.44. So what's the slope there? 1.44 is equal to the y value. So you start, it turned out that they were the same, the y value plus 1.44 times 0.2. Whatever it is. Should we do it? 1.44, 2 times that is 0.288, right? Now, oops, thank you. What's 12 cubed? Is it? That's the question. What's 12 cubed? Anybody got a calculator handy? Yeah, I know, I'm asking, why is that?
1 second.
Is it 1728? That's interesting. I think that's interesting. Why is that happening? Now you know what the next one is, 12 to the 4th. This was, well, it's 1.2 to the 4th, sorry. This is 1.2. This is 1.2 squared. That's 1.2 cubed. Now, look, what's the exact answer? Remember, we know that y is equal to e to the x. We want to find y of 0.4. What is that? E to the 0.4? Yeah, but what is it? How close are we? So I'm going to find out if I can get my... Okay. To trick it. Okay, so I'm going to quit. No, I'm not. E to the 0.4. Come on. I don't know. What did I do? Oh, look at that. How did I do that? Because I had my marker in my hand. That's why. Let me try that again. Then you're going to do a step size of 0.1. That's even more interesting. 1.492. So we have an overestimate. You sure about that? I don't think so. Is it? Okay. There we go. Okay. Second e to the x is 4. Oops, it's 0.4. Okay, guess what? We do this again. But now we have 0.1. So we're going to have to do quite a few more iterations. Okay. Eric? It's fine, but don't keep talking. Okay, we're starting at what? 0, 1? Is that right? Okay. So what's the slope? 1. So it's 1 plus 1. And now my step size is 0.1. So this is 1.1. Now you're going to be here at 0.1. How many times are we going to have to do this? 4. And this is going to be what? 1.1? So this is 1 point. Add those. Oh, no, it's just, sorry, wrong function. So I just wrote it down wrong. 1.1. Okay, so it's 1.1 plus 1.1 times 0.1. So it's 1.21. I am squaring it again. But you know what else? Let's do the next one. It's 0.2. So then this is 1.21. And what's the slope? 1.21, right? So it's 1.21 plus 0.1. Sorry. Yeah, okay. This is 1.21 times 0.1. That ends up being 1.331. Anybody recognize that pattern? That's Pascal's triangle. Okay, let's do 0.3. 0.3 is going to be 1.331. 1.331. So then it's 1.331 plus 1.331 times 0.1. Anybody have a guess what that is? 1.4641. And we got to do one more time. Oh, no, we don't. Because this is 0.4, right? And there's my answer. 1.4641. If I go further, I've answered the question wrong. Well, let's look. The real answer is 1.49182. Not bad. Remember, an exponential function grows really quickly. So you're going to, even with a small step size, it's going to get off pretty fast, actually. What's 11 cubed? Yeah, well, use your calculator and tell me what 11 times 11 times 11 is. I know it's 121 times 11.
1,320. That might be in the area. 1320 is the 1320.
Isn't it 1331?
1331
Yeah,
is
it is.
11.
Now, why would that be? Oh, yeah, that makes sense. I'll leave it to you to figure out why Pascal's triangle and that why that's whatever this number is, squared, cubed, fourth. But why is that connected to Pascal's triangle? Should bother you. You're happy with not knowing. Okay, whatever. Okay. Now, the other part of the assignment was to do some FRQ. So we're going to do one more problem. And this is 2012. You have the packet. You lost all your packets? I gave you the packets a long time ago. There you go. That's 2012. Number 4, no calculator. Personally, I would do the whole thing. Because you know what? It's all fair game now. Because I've taught all this. So if I give this to you on a test, You'll have to do all of this, even though this is not chapter 7. Well, this shouldn't be hard. Write equation for the tangent line. That's what we just did. That's a Taylor polynomial. This is the only thing that's a little bit off with the rest of it. You're going to find the area, but you should do it. C, use Euler's method starting at x equals 1 with 2 steps of equal size to get 1.4. What's h going to be? 0.2. Yeah. Now, this is the double bubble problem. This is the AB piece right here. AB students will not see that question. It is not common. Just one double bubble. So you have to get 60% of this exam has to be AB. So of your, you have 3 that are AB, exactly the same as the AB students. Well, hang on. And then, so you have to have part of this be AB, part be BC. Okay, how do I know it's 0.2? I'm starting at 1, and I want to get to 1.4, and I want it into 2 equal step sizes. 2012, number 4. No, I have no idea what color it is. In AB, they're all white. It's pink, somebody said. Okay, so Euler's method is part C. Why not do D? I want the Taylor polynomial, the second degree. Guess what this is? This is the first degree Taylor polynomial. They just want you to do this and add in the rest of it. So you should do it. Do I have to do it with you? This is 2012 on the last part, but A is a Taylor polynomial. When you do the equation of the tangent line, it's the first degree Taylor polynomial. If you haven't made that connection, huh? Equation of tangent lines is a Taylor polynomial. We just don't tell the AB students that that's what it is. So now that you've done it, you come back and look at it, hopefully you can connect and say, hey, they are the same. Okay, Marshall, you need to do the problems. This couldn't be any more relevant. Your test next Friday is going to be all AP questions, and they're not easy. That's why it's with a partner. Probably. Huh? AP. Not AB. AP. Okay? So you should try it. Do you want me to lead you through this? This is school. It is. I'm looking at. Poor child. Okay. Which one do you want to do? Euler's method first? Okay. The top is Euler's method, if you think about it. Okay. Do you want to use the chart? I like the chart. And you should finish this problem. Because if you don't remember how to do it, then that tells you that you have some work to do. Okay, we're going to have to look at that, by the way. Okay, then I want dy dx. And then I want to take the y value plus dy dx times the step size of 0.2. Now, where am I starting? X equals 1. What's the y value for x equals 1? Oh, there it is. F of 1 is 15. You're done? This is 1. This is 15. And what is the slope? Yes, this is C. What is the slope? Oh. dy dx at x equals 1 is what? What's the slope? 8. It's in the chart. That's why they wanted me to scroll up and get the chart. So it's 15 plus 8 times 0.2. What does that give me? What's 0.2 times 8? 2 times 8. You wish it. It's 1.6, so this is 16.6, correct? Did you guys get that? The first one? So this is 1.2, and this is 16.6. Now, what's the slope at 1.2? Because they told me. And they give you this for the Taylor polynomial. Okay, so what's the slope at 1.2? It's 12. Kind of weird. So it's the y value plus 12 times 0.2. That's going to be 1.4. Can you leave your answer as 16.6 plus 12 times 0.2? Yes, I would. Full credit. Because if you do it wrong, you're going to be in trouble. 16, and I would write it. I personally would write it out. I'm not very good at this stuff. 24, but it's going to be 2.4, correct? So that ends up being, 17. What did I do? Yeah, don't ask me what I'm doing. Okay. That's 2 points. That's 2 points. Do you want to do the Taylor polynomial next? Remember what the Taylor one is? It's f of a plus f prime of a x minus a plus f double prime of a. So there, guess what? They tested the Taylor polynomial twice in this exam. A squared over 2. So where are we writing this? We're doing f of 1, right? Yep. So it's going to be f of 1 plus f prime of 1, x minus 1 plus f double prime of 1, x minus 1 squared over 2. And now I just go to my table and find this. F of 1 was 15, right? It's 19. What's f prime of 1? They told me f prime of 1 is 8 times x minus 1. That's the equation of your tangent line for part A, by the way. Plus, what was the second derivative? 20 x minus 1 squared all over 2. Do they ask us to use that to approximate f of 1.4? Do not multiply that out. It's 15 plus 8 times 1.4 minus 1 plus 10 times 1.4 minus 1 squared, and that would be okay. But I want to know what it is. Okay, it's 8 times 0.4 plus 10 times 0.4 squared. 3.2, right? Let's see, that's 0.4 times 0.4 is 0.16 times 10 is 1.6. 19.8. We got 19 in our Euler approximation. So it's 2 points, probably one for this and one for that line right there. That's my guess. So it'll be 5 points for the other part. And it is time to go.